lesson 6.4 takes us into polar coordinates, okay? Something different. We're going to spend 6.4 and 6.5, I think, looking at polar coordinates, okay? What you guys have done over the years. Sometimes you'll hear talking about, I don't know if you guys remember the vocabulary, like a Cartesian graph. Okay, that's your XY graph. But you guys are used to doing rectangular coordinates. And rectangular coordinates are coordinates that are of the form. What's an ordered pair look like? X comma Y. Okay, so those are your rectangular coordinates. Now, what we're going to be looking at, and what we're going to be doing is we're going to be connecting, okay, how does a rectangular coordinate connect with a polar coordinate? A polar coordinate is of the ordered pair r comma theta. Okay, r comma theta, where r represents radius and theta represents the angle, of course. Okay, now there are 4 relationships between rectangular coordinates and polar coordinates that you need to be familiar with. Okay, and those are the ones that are going to help us, if we know one coordinate, convert to the other coordinate and vice versa. Okay, so with this in mind, let's see, do I want to draw the picture first or do I want to fill out the 4 pieces first? I think we'll draw the picture first. Okay, so if we think about a point, okay, so I'm going to use this right here, and I'm going to call it point P. Okay, we think about point P here. Now, in terms of rectangular coordinates, how do we get to point P? We do what? We go over so far in terms of X, and then what do we do? We go up so far in terms of Y, correct? And so point P, one of the names for point P, as I mentioned above, is X comma Y. Now, with that in mind, okay, keep in mind, we're used to this being the x-axis and the y-axis, correct? Okay. Well, in doing this, you guys, we've done some of these right triangles this semester in trig, right? We created a right triangle. Let's see, I'm trying to think, what else do I want to talk about here? What is this point called in rectangular coordinates there at the center? It's the origin, and we also refer to it as 0, 0, correct? Okay. I'm just going to write it as 0, 0, but yes, to origin too. I like that too. Okay, they're both true. Okay. Now, let's talk rectangular, or that was rectangular coordinates. Let's talk polar coordinates, okay? Instead of this being an x and y axis, this x-axis is referred to as the polar axis. Okay. The y-axis doesn't really exist, so we don't have another name for it. Okay. The center in polar coordinates, it's not an ordered pair. It's just 0, or it's also referred to as the pole. And then I talked to you guys about the polar coordinates are r comma theta, yes? So r, where's my radius? My radius is my hypotenuse, right? There's your radius. And then your theta is your angle here. So your theta is your angle of how far we are from our polar axis. So the same, idea as the unit circle. And so in this case, your point would be referred to as r comma theta. Okay? Now, I'm going to go through and we're going to talk about the 4 connections that we have between the two. with these 4 connections, it will help you to be able to go back and forth. Okay. One thing that can help. So this relates back to our unit circle. X is equivalent to R times cosine theta. Okay, so X is equal to the radius times cosine of theta. Now, X pairing up with cosine should make sense to you after talking about the unit circle. If X is equal to R cosine theta, what do you think about Y? Yeah. So Y is going to be equal to R times sine theta. Okay. Those are the 2 pieces that can be used if you know a polar coordinate. So if you know R and theta, you can use those to find X and Y. And we'll go over some of that on the back. Now, the other piece of information, or going the other way, we're going to talk about the fact that tangent of theta is equal to y over x. Because here's theta, right? Here's your angle. And the tangent, opposite over adjacent, is y over x. And I guess if you want to, we could look at cosine and sine in that way. I didn't think about that. But when you talk about sine of theta, for instance, sine is opposite over hypotenuse, but then you just multiply the r over. Cosine of theta would be adjacent over hypotenuse. So x over r, multiply the r over. And then the last one, what's this triangle tell me, guys? X squared plus y squared is going to equal r squared. Okay, so those are your 4 connections, and we will be using those when we work on the back side of notes to go back and forth between the 2. Okay? Questions here? Okay, so let's practice a little bit of graphing. Okay, and so first of all, 2 vocabulary point words that I already mentioned up above. Now, I didn't find the right graph to really help with this, but the dark line. There's your dark line, folks. Okay, that's what we're talking about for dark line. Your dark line, it's not the x-axis, it is the polar axis. I also have that it is the ray from point 0, if you would, for your description. So is the ray from 0, which represents that center. What's the center called, according to what I already said? What? Okay. It's not the origin, it's the pole. Okay. So it's not 0, 0, it's not the origin, it is the pole, and it is point 0. Okay? Now, with this in mind, let's practice plotting some points. Thank you. Okay, so notice XY coordinates, we do what? First coordinate tells us left or right, second coordinate tells us up or down. Now, on here, you'll notice what it says. First, plot the theta, and then the r value. So it's not second value, then, or first value, then second value. We kind of reverse it. This is backwards from x and y. So we're going to start with point A. Point A is the ordered pair 3, 2 pi over 3. Okay, let's pause. We probably need to do something here before we get started, don't we? Our graph could probably use some labels. Okay, let's put a few labels on this graph before we get too far into this, because otherwise it's going to be really difficult. As in, and I'm talking about labels, I'm talking about my angles, yes? Okay, guys. We have 0. Can we get the 4 big ones? We have 0. What's up top? Pi over 2 to the left. Pi. And at the bottom?
3 pi.
And polar coordinates is one where it's done in radians. Okay, I don't remember usually seeing degrees. Now, as soon as I say that, there could be some degrees pop up that I'm forgetting about, but I feel like it's usually done in radians. Okay. Besides that, now, this one is similar to the one on my sideboard, where it has more lines than what we need, doesn't it? Okay. We're used to there being 3 lines in each quadrant. So if we look at quadrant 1, the middle 3 lines are pi over 6, pi over 4, and pi over 3. Now, this is something, especially with those of you moving on in math, in any way, shape, or form, whether it be at high school level, college level, you need to know your basics about trig when you get to calculus, and they're not going to provide you with a, unit circle to rely on. So, first quadrant you should have an idea of. Second quadrant, keep in mind, it's these same angles, right? But over here in the second quadrant, so between pi over 2 and pi. What I think of on my second quadrant is they're all right before pi. So, like over here on the right is pi over 6. On the left, what's the pi over 6 angle that's going to be right before 1 pi? 5 pi over 6, because 5 6 comes right before 6 6. Does that make sense? So this line up, we're skipping a line, right? That's 5 pi over 6. The middle line in any quadrant is your quarter line, your pi over 4. So here it's 1/4. What's the fourths going to be right before pi? 3 pi over 4. And then we have the farthest line from the x-axis is a third. So 1/3, what comes after 1/3? 2/3, because then pi is going to be 3/3. So this is 2 pi over 3. Am I making a little bit of sense? Okay. Next quadrant, do the same thing. Now these, in this quadrant, I think of what is 1 past pi. So what's right past 6 6, 4/4, and 3/3? So what's right past pi in terms of sixth? 7 6. So 7 pi over 6. In fourths, right past 4/4 is 5/4. And in thirds, right past 3/3 is 4/3. And then the last quadrant, we're at the tail end. I say we're right before 2 pi. Okay, so right before 2 pi is where we're at. If we go ahead and do thirds, what's right before 6/3? 5/3, so 5 pi over 3. Fourths, you're going to be right before 8/4, so 7/4. And sixth, right before 12/6? 11/6. Okay, those extra lines are if you're breaking the unit circle up into 12ths. And we don't traditionally use those. Okay? So, not that you couldn't have just copied off your unit circle or copy it from the sideboard, but, okay. Now, let's go back to point A. 3, 2 pi over 3. So first thing you need to do is you need to find the angle. Where is 2 pi over 3? Over in quadrant 2. Now, a radius of 3 means you are going 3 units out on that angle. Those are the circles. Each circle represents a unit of 1. So that means I go to my 2 pi over 3 line and I've got first circle, second circle, and third circle. And that is point A.
Those circles always going to be available for us, or are we going to have to draw them?
If you're working in polar coordinates, the circles will be on there.
What about like homework?
I have a piece of graph paper to give you for homework. Okay? So if you're not going to be here, make sure you grab a piece of graph paper. If you're not going to be here tomorrow, make sure you grab a piece of graph paper from me. But, okay. Are we okay with A?
Yeah.
Okay. Let's talk B. 4, comma, negative 3 pi over 4.
So it'd basically be 5 pi over 4 because it's the opposite way.
Okay. Positive 3 pi over 4 takes me counterclockwise up here. Negative 3 pi over 4, remember, is going to go clockwise. So basically you want this angle up here, but down there. So negative 3 pi over 4 is indeed the same as 5 pi over 4. And then 4 means we do what? Count out 4 circles. And that is point B. Okay, point C. Should have started with this one, really. 1 comma pi over 4. You guys got it? Pi over 4, and you go out 1 circle. So that is point C. Okay. D, are we ready for D?
Yeah.
Negative 2, comma 7 pi over 6.
So you go to the 7 pi over 6 line, but then you would go 2 circles in the quadrant 1, basically.
Okay, because think about it. Positive means, like in a normal situation, positive means we go right, so to speak, right? Okay, forward. Negative means you're going to go the other way. So like if we're graphing x, y coordinates, positive means we go right, negative means we go left. Okay, so go to your 7 pi over 6, which is here in quadrant 3. Positive 2 would take me onto that angle, onto 7 pi over 6. But since it's negative 2, you reverse yourself, you go backwards through the pole. What's the other line that connects with 7 pi over 6?
Pi over 6.
Pi over 6. And so on pi over 6, you're going to go a positive 2. So not that you have to write this, but this essentially ends up becoming the point positive 2, comma pi over 6. That's the same ordered pair. Okay? And that is point D. Okay. E, we're going to put these negatives together. E is negative 1, negative pi over 3. So, positive pi over 3 takes me up. Negative pi over 3 takes me down to what? 5 pi over 3. So we're going to be working with 5 pi over 3. Negative 1 does what? Takes me backwards. So positive 1 would be right here. Negative 1 is going to take me backwards through the pole to 2 pi over 3. And that is point E. Okay? You got the basics there. Okay. I have pretty much a polar graph very similar to this that you will have for just one polar graph, and you're graphing a handful of points like this so you can put them all in one graph. So I have a half sheet of paper to give you guys today or tomorrow. Okay? Now, I do want to flip over to the back side real quick to just kind of prep us. I know we don't have much time, but prep us a little bit for tomorrow. On the back side, in example 1, they give us polar coordinates. And they ask us to find rectangular coordinates, which means they're giving us polar coordinates. What are polar coordinates in the form of? They're of the form r comma theta. We're being asked to turn these into rectangular coordinates, which are of the form what? X comma y. Now, were there some connections we talked about on the front side of the paper? Yeah. I gave you 4, I'm going to call them conversions. And those conversions, x equals r cosine theta, and I'm just writing them here so we have them. Y equals r sine theta. Tangent of theta is y over x, and x squared plus y squared equals r squared. We're going to use those conversions. Okay. When they give me 5 and pi over 6, what values are they giving me? 5 is what? R. Pi over 6 is theta. They give me r and theta. What am I trying to find?
X and Y.
I'm trying to find x and y. Do you see how we can do that?
Yeah.
Because x is equal to what? Yeah. X is r cosine theta. We know that information, right? So x is going to be 5 times cosine of pi over 6. Now, I'm going to tell you, these are not calculator problems. These are know your values from your reference chart and unit circle. Okay? So, real quick, we'll finish this and then I'll stop. 5 times, what is cosine of pi over 6? Someone else, please?
Oh,
Cosine of pi over 6?
Sorry, I was still in the pi.
Square root of 3 over 2. So if I put this together, this is the ordered pair. I'm going to say 5 square root of 3 over 2. I also have a decimal version written down. I'll have to look and see what the answer key does. So in a decimal form, I have written that it's 4.33. Okay? Tomorrow you can do the same thing to find y, right?
Yeah.
Okay, remind me if I forget, this is where we left off. We will finish tomorrow, and I think we should have some work time tomorrow. If we get in here and get motivated and get moving, we should have some work time.